So today we're going to be talking a little bit about water activity, a little bit about what that is and why it's important. So water activity is an indicator of available water in the food. This water is available for enzyme reactions with microorganisms, things of that sort. So water activity, the equation is, I'm gonna draw it for you. It's A sub W equals RH divided by 100. Okay, so this is water activity equals relative humidity divided by 100. Okay, so you're asking me, how do we find the relative humidity? Well, relative humidity is found by measuring the amount of water vapor that's available in the headspace above the food product. Most of the time this is done with an instrument. There are several different instruments you can use. So once you get that, water activity is on a scale from 0 to 1. Okay, so 1 being pure water, then you go from there, and higher on the scale, which is the tissue products, I have some fresh tomatoes and an apple here, which will have water activity above 0.9, so that's high on the scale. And then in the middle of the scale, you'll have things like jelly and bakery products. This is pie, coconut pie. So those will be, which will be most foods, those will be between above 0.6 and through between above 0.6 and 0.9. And those will be what most of your foods will be in. And then you'll have the lower side that'll be below 0.6, which will be considered shelf stable. So this is ground coffee. It's actually fresh. And some crackers. So yeah, that's on the lower end. And so I told you that foods with higher water activity, you tend to worry about spoilage and things of that sort. So then they use the absorption isotherms, the adsorption, which is the addition of water, and then the desorption, which is the subtraction of water, and kind of they find the difference, which is the absorption hysteresis. Okay, and so what you do with that is you say, this is what I want to do with this product. This is how long I want it to be shelf stable, and then you can find things that will make it stable for longer. One of the greatest things that can be added to a food, or one of the greatest group of things that can be added to a food, are crystalline substances such as salt or sugar. And the smaller the molecule, the more water they'll be able to bind. So salt is a smaller molecule than sugar, so it will definitely bind more water in a product than sugar will. The only thing that you would have to worry about with that is, now there's a push on the market to have lower sodium, lower sugar content in food products. Then you would have to look at that and say, okay, how much salt do we want to add? How much sugar do we want to add? And of course, if you had something like jelly, you wouldn't want to add too much salt to it, because it would definitely change the flavor, and jelly is a sweet product. So now that we talked about that, we also want to talk about a little bit more about microbial growth. So in things like the apple and the tomato, they're not very shelf stable. You can keep them a week, 2 at most, before they start to rot or show microbial growth or mold. This jelly, I think we've had this jelly for a couple of months now, actually, and the expiration date is May the 1st, 2014, and this was bought in December, I think. So it has a longer shelf life because of all the sugar in it. It has a very high content of sugar, and it also has preservatives to help with the microbial growth, but that's a whole different topic. Okay, so, and also dry coffee. As long as we don't expose this to water, then we don't really worry about this having microbial growth or not being shelf stable any longer. So now that I've told you about what exactly water activity is,